So today we're going to be talking about similar triangles. Okay, and the heading of this is angle-angle similarity. So if you guys recognize that, that kind of looks like those old congruence, shortcuts that we knew. Remember, we knew that, for example, side, 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 we could use to prove two triangles congruent, or angle, side, angle, or angle, angle, side. Those are all congruences, right? Congruence is trying to show that two triangles are the exact same triangle. Here, though, we have this new shortcut, and this is only for similarity, right? We did not have an angle-angle congruence. We only have an angle-angle similarity, okay? So the essential question we're trying to answer then is, how can we show that two triangles are similar? Okay? We're actually going to skip this first little activity here, or whatever, this exploration. But basically the idea is that they were going to have us draw one triangle, just kind of freehand here, using a straight edge, and then copy two angles of that triangle to another triangle, but it was going to end up being bigger, like that. Okay? And then we were going to measure the sides, and we would find out the sides would be in the same proportion. And then since the angles would all be equal and the sides would be proportional, we could say that the triangles are similar. That's all. Okay? But we're going to skip ahead to the next page. Here's page 612. Okay? So here's 612. Okay? And basically there's the angle-angle triangle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles must be similar. All right? Because really, if two angles of a triangle are congruent to two angles of the other one, what do we know about that third angle? So again, if two angles of one triangle are congruent to two angles of another triangle, those third angles must also be what? Must be congruent, right? Because if we subtract those two angles from 180, we're going to end up with the same angle. Okay, so there's that. So really, all we need is angle-angle. Technically, this is like angle-angle similarity, but really we just need two angles, because the third one, if two angles are similar, or two angles are congruent in a triangle, the third angle must be the same too. So anyway, all right. So that was just that little part right there. And again, there's a proof here. We're not going to worry about the proof right now. Okay, we're instead going to go right over here to some actual problems. So we're going to apply angle-angle similarity. Okay, so architects and contractors use the properties of similar figures to find any unknown dimensions, like the proper height of a triangular roof. Okay, they can use a bevel angle tool to check the angles of construction are congruent to the angles in their plans. Okay, so we're going to find the indicated length if possible. So here in letter A, we're asked to find BE. So I'll kind of zoom in here on the picture. Okay, so there's our triangle, and we want to find BE. Shh, Josh. Thank you. We want to find the length of BE here. So I'm going to call that X, since we don't know what that measure is. We want to find that measurement X. All right. Now, we first need to determine if these two triangles are similar, right? We're not told in the directions that these two triangles are similar. So let's see here. Well, we just talked about angle-angle similarity, so let's see if we can come up with two angles that must be congruent. Does anyone see in this picture here any angles that must be congruent? Zara, did you? AC. So AC, that little marking means parallel, right, to ED. But name me two angles that are congruent. Kyle, can you? Sorry, A and D? Okay, how do you know that A is going to be congruent to D?
Oh, no, it just looks congruent.
They do look congruent. Matt, can you tell me why? What's the reason there? Oh, I think you were just going to say it. Well, no? No? All right.
Because, when you take A and you flip it, it's D.
Okay. Well, since we have parallel lines here, though, what special angle relationship do we have here, Skylar? Oh, okay, sorry. Yes, what kind of interior? Alternate. These are alternate interior. But you guys are all, using the right reasoning there. You can see kind of that they're going to be congruent. But these are congruent because they're alternate interior. All right. Skylar, you have another pair of angles here? Yeah, we have two vertical angles at B, right? We would call those like A, B, C, and then angle D, B, E. Those are going to be congruent as well. And then, E and C. And for what reason? Again, also alternate interior angles. So we know all three are congruent here. And so since we have three pairs of congruent angles, that means these are similar by angle-angle. So we can go ahead and say similar by angle-angle. Okay, but we're not done yet. Now that we know they're similar...
Well, wouldn't it be angle-angle-angle?
You can say angle, 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 but that's the same thing as saying angle, angle. It's the same thing.
Oh, yeah, it's just one more.
Exactly, because you know what the third angle is if you already know two angles. So, all right. So Xander, we need to set up a ratio or a proportion here that includes this x. So x in this triangle corresponds to what in this triangle? What does it match up with? X in this one matches up with which side over here? So, very good, the 54, exactly right. So we're going to write then x over CB, the 54, must equal, okay, so these two sides here, the 54 and the x, they correspond. Okay, and so we just need to come up with another pair of sides. So Matt, can you give me another pair of sides that match up? Okay, so A and C and E and D would match up, but unfortunately we don't have any measurements for those, so we don't want to use those.
Okay, well then D and B and B and D.
So,
I got it.
yeah, be careful. So it's not C and B
36
and...
54.
Okay, so the 36 for the AB and the 54 for the BD. Do you see that? That's what you were going to get to next. Right, got it. Okay, so we did x over 54. What's the order got to be for the other ratio then, Matt?
Oh, I thought what?
We did x from the big triangle over the 54 from the smaller triangle here, right? BE over CB. How do we have to set up our ratio for this? How do we have to set up our second ratio? Can I say 36 over 54?
No.
Yeah, no, because 36 is from the smaller over the larger. I have to do it in the same order I had before. So I did x over the 54, so I have to do the 54 here over that 36. It's always got to be, the same order. If I did the big over the little, it's got to be big over little. Okay, big over smaller, I'll say. Bigger over smaller. Okay? Very good. And Dominic, how do I solve this? Now we have it set up. What do we do? Very good, sir. Exactly right. 36 times x, 54 times 54. So we get 36x equals whatever 54 times 54 is. So 2,916. Okay? And then the last step here is to do what here, Derek?
Oh, put both over 36.
Yep, divide both sides by 36. You got it. Very good, sir. Okay, so 2,916 divided by 36 is 81. And so there's our missing side. That's the answer, 81. If you want to, you can put it back up in the picture here. 81. Yes, you
So
can.
everything we did makes, complete sense.
Good.
But, I mean, so, since they're both, similar figures,
Mm-hmm.
remember, the first step after we found it was angle.
Yes.
Angle.
Yep, after we decided that, yep.
So, and we found out that x would be equal to CD.
They correspond. Be careful, I don't want to say equal because they're not going to be equal. They correspond. They match. Well, I mean, A in the picture, first of all, in the picture, we can see that BE, right, is not the same length as BC. It's visually seen. Now, obviously, sometimes we can't trust the picture, right? So let's look at another pair of sides. Well, AB and BD, they correspond, right? A and B, that side AB will correspond to this side this side here, BD. You agree with that, right? That this side matches to this?
What side?
AB of this triangle matches to BD of this triangle.
I mean, yeah, they're not congruent.
Well, that's what I mean, though. They match. They correspond. This side is like this side and this bigger triangle.
Okay.
So, therefore, since these don't match, we know that these are not going to match as well.
Okay.
Does that make sense now? Okay. Now, let's look at the next one here. So, any other questions on that? Any other questions on that? This next one's a little bit trickier because the triangles are overlapping now. Makes it a little bit more challenging. So letter B, I'm going to zoom out slightly here. Letter B, we're asked to find RT. So here's the length RT right there. So I'm going to go ahead and zoom back in. Okay, zoom back in here. And we want to find this full length right there. Oh, you can't see it, sorry. I was not adjusted properly. Okay. First, we need to decide, though, are these two triangles, and yes, there are two triangles, right? Here's one triangle, and then there's the bigger triangle. Are these two triangles similar? Well, do we see any congruent angles here?
Yeah.
Yeah, we do. Okay, so let's see here. Xander, can you name me a pair of congruent angles between this triangle? So say that one more time. Yeah, angles. Sorry, just name me two congruent angles here. Yeah, so, and we got to be careful here because S could mean one of these two, so we should say like R, S, V, but you can see it's marked there, and T is okay to just say there. R, S, V, and T are going to be congruent, that's right. So we have one pair of congruent angles. Do we have another pair of congruent angles here? This one might be kind of hard to see. We don't know that these two angles are congruent. They're not marked that way, but both of these triangles, Derek, both of these triangles have angle R in them.
R is congruent to R.
So R is congruent to itself. So these are similar by angle. Okay? And in fact, I'm going to actually name the triangles here. So I'm going to go, let's see here, triangle RSV. So RSV, in that order, will be similar. Okay, similar to. So Taylor, if I name that first triangle RSV, how do I have to name this second bigger triangle? Very good, triangle RTU. Perfect. Okay, you have to name it in that same kind of order. So RSV then matches to RTU. So now we have that.
Mr. Wu, what if it's
Yes.
not angle?
We have other methods. We're going to get to those in a little bit after angle.
You said like angle is angle.
Truly, right.
So where's the other angle?
So once you know that two angles are congruent to two other angles, that means their third angles must be congruent no matter what.
So V and E, V
So
and U.
will be congruent, yes. Mm-hmm.
Okay.
Yes.
So wait, so what happens if they're not angle?
We're going to look at those later. We're only doing angle because that's all we've got right now. Okay. So let's see here. Let's go to Jaden now. This side X, this full side RT, which we can also identify here in the similarity statement, RT, what does that match up with in the other triangle? RS, which we, in the picture, it tells us that RS is what length? 10. Perfect. So we can write X for the big triangle over 10 for the smaller triangle. So this X, this full side X here, matches up with the RS side of 10. And that's got to equal, and Jaden, can you give me another pair of sides that we know are corresponding here? So SV, sorry, NTU, that's right. So again, we got to be careful here. We did the big side over the smaller side, so that means we have to do what over what here? No, it's still bigger over smaller then. So no, that's okay. It's okay to not know it. That's why we want to work on this now, because this is the classwork. So it's got to be what over what here? Just give me the numbers. What's going to be on top? 12, exactly. Over the smaller side, 8. There you go. Okay, they're corresponding sides. And again, we can see TU right there matches up with SV. So it's TU over SV. All right, very good. And let's hear, Krishna, how do we solve this then? Cross multiply. So it's 8 times x equals 10 times 12. So it's 8x equals 120. And then Krishna, last step. Divide both sides by 8. You got it. All right, so 120 divided by 8 is 15. Okay, so that means RT equals 15. Okay, if you want to, you can kind of like put that up in the diagram there too if you'd like. I'll zoom out just a bit so we can get more of the picture in. Okay, there it is. Questions on any of that? Questions on any of that? We're all good? No questions? We're cool? All right, so let's flip the page here then. All right. All right. So I want to look at a common error here in number 5. So let's take a look at not the reflect part there for number 5. It's the discussion, and I'll just read the directions here real quick so I can stay zoomed in. But it says, when asked to solve for y, a student sets up the proportion as shown. Explain why the proportion is wrong. So you can see here that the student correctly did 14 over 10, right? Those two parts clearly match up, 14 over the 10, but then they did y over the 8. What's the error here? 14 over 10 is correct, but what's the problem with just putting y here? And this might be hard to see, because I know this is a common mistake for a lot of students. So, kind of, yes, but here's the thing. 14 is one full side here. In fact, let me do it this way. What the big triangle here, we can name this, is triangle ABE. Right, so I'll start at A, go to B, go to E. And we'll say that it is similar to then, what's the smaller triangle's name got to be? Anyone want to volunteer and just tell me? Julio, what's it going to be?
CDE.
Yes, very good. Triangle CDE. So they took AB, the first two letters there, and put it over CD, which matches the first two letters there. Then they took AC, though, which is Y. Is AC a side of a triangle? No, it's only part of a side of a triangle. You see the problem here. ACY is only part of a side of a triangle. We need the full side here, AE. What is the length of this full side, or how can we describe the length of that full side?
What do you mean 8y?
Not 8 times y,
8 divided by 1?
8 plus y. We're going to add the two pieces together. So this should not be y, it should be 8 plus y over then the smaller side here, 8. That fixes it. So you see here, just saying y, that's not the full side of any of these triangles. Y is just a piece. It should be CE over AE. AE's length is y plus the 8. So it should be 8 plus y over 8 equals then the 14 over 10. And then you can cross multiply and solve there.
Because they're trying to find AE and not AC.
Well, when you set up the proportions, it's got to be sides over sides. AC is not a full side. It's only part of a side. You need to give me the full side length there, y plus the 8.
Right, so you're finding AE.
Yes, you want to find AE, exactly right. AC is not a side of any triangle, so you can't just use that, okay? So, let's take a look here at number 6, okay, and see how we do. Let's see. So, yeah, so it says here for number 6, I'll zoom out a little bit. A builder was given a design plan for a triangular roof as shown. Explain how he knows that triangle AED is similar to triangle ACB, then find AB. Okay, so let's do this one here together. Maybe I'll have you guys try the second one, okay? So, hello, sir. Okay, we're on page 614 there. And remind me to help you get you loaded up there. So first of all, we have to determine, are these two triangles, is this triangle right here similar to this bigger triangle right here? All right. Do we have any congruent angles here? Can anyone raise your hand and show me or tell me any congruent angles that we have in this picture? Okay, so angle C is congruent to angle B?
Never mind.
Yeah. So, okay, so let's do that one first. So A and A, right, because they're being shared, so they're going to be congruent. And then C and D?
No, C and E.
Ah, C and yeah, so C and E, they're corresponding, right? We have parallel lines crossed by transversal, and those two angles are kind of in the same position. So C and E.
But D and B.
Exactly. You could actually say the same thing for D and B as well. Okay, beautiful. So, let's see here. All right, Ramel, can you help me set up one of my proportions, or my ratios here, Ramel? We know these two triangles are similar. We can say that, triangle AED is similar to triangle ACB. Okay, can you give me one pair of corresponding sides? So what do you say? You what? You pass, all right? Let's see here. Chardez, how about you? Can you give me a pair of corresponding sides here? Okay, so 6 is from this triangle. And do we want to say that goes 6 over the 9 then? So they're both from the same triangle though, aren't they? Like 6 is this side of the smaller triangle, and 9 is the side of the smaller triangle. So, which one, 15? Yeah, so which one should it be? Yeah, 9 and 15, because again, if you look here, 9 is ED, right, which is the two letters there, and 15 is the BC, which is the last two letters there too. So that's how we know they match up. 9 over 15, very good there, okay, equals, And let's see here. I'm trying to find AB according to my directions.
Can we do 6 plus x?
1 second. Hang on, let me get this marked here. So AB, we'll call that full length there, AB, x, because we don't know what that is. That's what we're trying to find. Okay? And so actually here we don't need to do 6 plus x there. We can just say the whole thing is x, the way we set it up. We want to find AB. Okay? And so we did 9, the smaller side, over 15, the bigger side. So what's our ratio got to be for this next one? 6 over x. Very good. 6, the smaller side of the one triangle, over x, the full side there. Yep, and that's it. Okay?
So now you're going by bigger, what side's bigger to put on top?
It's always, it doesn't really matter. I just, because Chardez chose to do 9 over 15, she could have told me 15 over 9, I would have written that too, that's right. But that's just, they match up. Since she said 9 over 15, we had to then say 6, the smaller side in the triangle, over the x.
15 matches up with x because they're both longer than the other one?
You can kind of use that idea, but you can think of it just this way. 15 is a measurement of BC, which is the side of the bigger triangle, right? X, AB, which we called x, is then also a side of the bigger triangle, so that's how we know they're part of that same triangle. Okay, so cross multiply here, right? So we get 9x, and 6 times 15, which is 90, and then Chardez will be the last step here to solve this equation. We have 9x equals 90, so we, divide both sides by 9. So x is 10. And that's our answer. We wanted length of AB, so it is 10. Okay, it is 10. All right.
So how about you do something like number 7?
Yeah, so actually, now that I'm looking at 7, I think we should do this one together too. Don't worry, guys. We're getting close here. I know this is a lot, but you guys are doing a great job right now. So I'm going to keep going because yes, this one's kind of tricky too. Okay, it's not like the one we just did. So all right. So the next one, number 7. So any questions on this one actually before I move on? Questions on 6? All right. So 7, we're asked to find PQ. Now, is PQ the full length of any of our triangles here?
No.
So you guys hopefully see this here. PQ is not the full length, but again, that's what we're trying to find, so let's call that x. Since we don't know what it is, we're going to call that length there, PQ, as x.
It's not even part of one triangle.
Well, it's part of the side of this triangle right here. It is part of the side of this one triangle right
Yeah,
here.
but it's not part of the other one.
You're correct, it's not part of the other triangle, that's right. So, we have a right angle here, which means on the other side of S, what kind of angle do we have? A right angle, right? So you can put a little right angle mark there if you want to. And so then these two triangles are similar by what? Well, angle. There's two, and I know, Jason, you weren't here for this, but if we have just two angles in one triangle congruent to two angles in the other triangle, those triangles will be similar, and they're similar by angle. Okay? And I'm going to go ahead and name the congruents here. So let's see here. So Jason, can you name this triangle for me, just however you want? PSR, perfect. PSR. We're going to say that is similar to, okay, PSR, what does that kind of correspond to over here? TSQ. Very good. Good job. That's important to name those correctly. All right.
Okay, if I just switched it around.
Yep, as long as, again, you match up corresponding pieces, that's okay. All right, so Garrett. So pick, can you find any corresponding sides here that we know? For example, this 9 here, Garrett, that's QS, right? QS is part of the one triangle here. What does that correspond to in the other triangle? RS. So that means 9 matches up with what measure? Where's RS in this? What's the length of RS here? 12. So it's going to be 9 over 12. That's our first ratio. 9 is QS. It matches up with RS 12. Okay. And so let's see here. The only other measure for that small triangle we have is 15. So that's TS. We'll say that's 15 over. What does TS, Garrett, correspond to over here? PS. Now, PS's length, we don't quite know, do we? We know that QS is 9 and P to Q is X. So what could we use? What expression could we write for PS? 9 plus X. You see that, Garrett? We're going to add PQ together with QS and get 9 plus X, or X plus 9, whatever you want to say there. I'll put 9 plus X since that's what Skylar said. Okay, so we're going to write that. Again, we have the TS there, that matches up with the PS, so it's 15 over 9 plus x. Okay. And now to solve this, we're going to cross multiply. 12 times 15 is pretty easy, right? It's 180. And then the 9 gets multiplied with the 9 plus x. And I'm going to write this very carefully here. I'm going to do like a little intermediate step. See that right there? That 9, right, is next to the parentheses. So what does that mean we have to do with that 9? We have to distribute. The 9 gets multiplied to the 9 and to the x. So it's 9 times 9 and 9 times x. We get 81
Why can't we just do it in our calculator?
plus 9x. Well, because you can't, this won't multiply in your calculator like that.
I know, but it's kind of like simple, because 9 times 9 is 18, and then you're multiplying the rest will be 9 plus x.
Right, if you can do that in your head, that's fine. I just wanted to write it out very explicitly for other students. That's all. You can skip steps if you feel comfortable doing so. Okay, 81 plus 9x equals 180, and then so to solve here, let's see, Zari, can you tell me what would be my first step to start solving this now? You got it. Good job. Okay, so you got 9x equals 99. Very good there, Jason. And Jason, last step, what are we going to do? Divide by 9. Okay, and so we get x equals 11. And that's what we wanted to find, right? I'll go over here in my picture. PQ is 11. So there it is. All right. All right, so there's that. Any questions on that? That one's a little bit trickier because you only had like parts of sides. But again, just match up. I mean, really, guys, the key is to match up corresponding pieces. The 12 matches up with the 9, and the 15 matches up with the 9 plus x. Okay. All right, so there's other similarities we need to be familiar with. Side, 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 which is familiar, right, from congruence. If 3 sides in one triangle are congruent to 3 sides in another, we know that the triangles are congruent. If 3 sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. So now we're talking about proportions for side, side, side similarity. And then for side, angle, side similarity, if 2 sides of one triangle are proportional to the corresponding sides of another triangle and their included angles are congruent, then the triangles are similar. Okay? So now we got side, 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 angle, side, but that's for the proportional relationship. They don't have to be equal, but they should be in the same proportion. All right? So let me just show you that here in practice. So for example here, we have 2 triangles. Okay, and we want to see if they're similar. All right, so let's see here. So Gabe, pick a side of one of these triangles whose measure that we know. So pick a side for one of these 2 triangles, either one side from this big triangle or one side from the smaller triangle. Or sorry, the smaller triangle and the bigger triangle. Smaller triangle, bigger triangle. So you said which one, sorry? MN. So that's 4. So we're going to put the 4 down, and then 4 from that smaller triangle, Gabe, what do we want to say that's going to match up to down in the bigger triangle? The 6. So let's say 4 over 6, good, okay? And let's see here. I know that NP should equal RQ, but I don't have those measures, so we don't want to go to that one. Let's see here. I do have the measure MP. What's that measure, Gabe? 8. Now, MP in the smaller triangle, what does that correspond to in this bigger triangle? Can you name me the side? MP is kind of like the longest side of the small triangle. What will that correspond to in this bigger triangle here? What side? MQ, right. What's the length of MQ? What's the length here from M to Q? Yeah, 12. Good job. 8 plus 4. Exactly right. Beautiful. All right, and then let's check to see if these 2 are equal. So let's see here. We can simplify them, right? Or we can just do the division. Let's just do that. I like this way. So we'll do 4 divided by 6, and I get 0.6 repeating. And then 8 divided by 12, 0.6 repeating. Whoops, I did way too much repeating there. There we go. Okay. So Gabe, are these 2 sides in the same proportion? Same ratio? Yes. And we have congruent angles here. So what similarity is this? Is this angle-angle? We had side, angle, side. We did 2 pairs of sides were in proportion, and then we had 2 congruent angles there. So this is side, angle, side similarity. All right. And so we can actually...
How is it side, angle, side?
because this side MN was in the
Okay.
same proportion, so MN over MR was the same as MP over the MQ,
Okay.
and then there was the angle between them that were equal, so side,
that's
angle,
what makes
side.
it side, angle, side.
Mm-hmm.
Okay.
Yes, the two sides were two pairs of sides were proportional, and then the angle between those two sides were equal.
Okay.
Side, angle, side, side, angle, side was proportional to side, angle, side, the full length there.
Oh, okay. I
Okay?
get it.
So I have two questions.
Okay.
So, I cross multiplied and I got 48 equals 48.
That works too. Yep.
Okay, so like how come, like what changed from doing what we did on the other paper to
Mhm.
this problem?
What do you mean as far what changed?
Because
So
you solved it differently. You did
Right.
decimals instead of cross multiplying and doing that.
same thing. There's like I was trying to show you guys back on Friday when we did the warm up. There's multiple ways to determine whether these ratios are similar. You could cross multiply to determine it. You could do the division to determine it. You just want to show that these two, the left hand and right hand things, are equal. So
So if it
either way is
says-
fine.
If it says determine whether the given triangles are similar,
Yes.
you just find the decimal, and then if it's telling you to find a side or a segment,
Mm-hmm.
then that's when you do what we did over here.
Yeah, you do the, yeah, it's always about ratios. You always want to use the ratios to set it up. Exactly right. Sometimes you'll have an unknown part of the ratio, that's where you do the cross multiply to solve for the variable. Sometimes you'll know all the pieces and you just see if they're the same, that's all. It's a matter if you're trying to find a side or if you're just trying to show that they're proportional. All right, last one here, letter B. Now some of you guys can look at this and already determine what kind of similarity are we going to be shooting for here. Are we shooting for angle here? Are we shooting for angle? Well, let me ask this question. Do we have any information about the angles in this picture? Yeah, no, so probably not angle. And in fact, probably not then side, angle, side, because again, there's no angles given to us. So what similarity are we probably going to try and shoot for here?
Side, angle, side.
We don't have an angle. Side is what we're going to shoot for here. So now it's just a matter of setting up those proportions very carefully, okay? We want to make sure we match corresponding parts, okay? So let's see here. So Taylor, can you give me a pair of sides that are going to match up? Okay, so ML, GH, perfect. So that means we should say that ML over GH, which is then, what's the measures of those sides? 12 over 8, perfect, okay? So what's another pair of sides? Let's go to Ikeva. What's another pair of sides here?
Well, I like to write out my
Okay.
So can I do that?
Okay, I'll go to someone else. You go ahead and do that. I'll go to someone else, and then I'll come back to you maybe for the next one. Okay. So Cordell, can you give me a pair of sides? ML corresponds to GH. What's another corresponding pair of sides here? Or matching sides? So JH and M, beautiful. So that would be, let's see here. So I want to be careful. Since I already did ML over GH, I'm going to do NM on top. Okay, because again, ML was on top. That's from the right-hand triangle here. So NM I'm going to do also on top. And then you said that was JH then. Okay, good. And what are those measures then? It's going to be what over what for mine here? NM is what length? 15, good. Over the JH, which is 10. Okay, question?
How do you tell, how can you tell, like it not says it up here, but...
Right, how can you tell that they match?
What if it didn't say that?
Okay, great question. So what if we weren't told the similarity statement here? All right, well, here's the thing. Let's just start with like what Cordell said here. MN is 15. And let's just say you have no idea. How am I supposed to know which one of these three sides to match it with, right? Well, 15 here is the biggest of the three sides. So it has to match to the biggest of the three sides here, the 10. Must. Same thing, pick the smallest side, 6. That's the smallest side. It has to match to the smaller of the three sides over here, which would be the 4. Okay, that'll also help guide you, Jaden, if you're having trouble like seeing it or whatever, use that to guide you. Biggest side matches the biggest side, small side matches the smallest side. Okay?
Can you write your similarity statement, because I think mine's wrong.
Oh yeah, we'll get like for the two triangles.
Yeah.
Yeah, well let's prove them similar first, and then we'll write the similarity statement. Okay? So last one here. Let's go to Garrett. So we already did. What's the last pair of sides that we have to name here? We did the ML over the GH. We did NM over JH. What's the last pair there? And this might be hard. I'll get you started here. How about, it starts with ln, and that's got to be over what from this triangle? So ln right here, GJ, there you go, very good, GJ. And what is length of ln? It's 6, and GJ is 4. Okay. And so now we'll just check to see, are these the same? So 12 divided by 8, 1.5. 15 divided by 10, 1.5. 6 divided by 4, 1.5. Okay, so Garrett, are these triangles similar? Yes, by side. Okay? So let's name these, let's do this similarity here. So go ahead, Garrett, why don't you name this triangle for me real fast. Just however you want to name it, whatever letters you... Oh, sorry? MLN is similar to. Now, since you said that, so, yeah, you said, let's see, MLN, so HGJ. Very good. Triangle HGJ.
That's what I have.
That's a similarity.
Then why would you do NM over JH?
Side. MN is the first and third letter. JH is the first and third letter. So that's why they correspond. Those sides correspond. That's the idea there. Okay? M and N are the first and third. J and H are the first and third. So that's that side. Okay? All right. Whew. So I'm going to finally get you guys started on the assignment here. So your assignment, okay, once you get started on, all right, that idea.